Hello everyone, welcome to this lecture. In this lecture, I am going to discuss about simple storage service, that is S3. Let's have a brief intro about S3. What is Amazon S3? Amazon Simple Storage Service provides developers and IT system administrators with secure, durable, highly scalable cloud storage. And we all know that Amazon S3 provides object storage with a web interface over the internet, where it is built to store, protect, and retrieve data from buckets at any time from anywhere on any device. Here, a user creates a bucket, and the bucket stores objects like files, videos, pictures, and any other documents in the cloud. And it is commonly used to store data for analytics, backups, and disaster recovery. Here, the main thing is each individual object should not exceed more than 5 TB, which ranges between 0 bytes to 5 terabytes. And S3 is extremely durable, which deliver 11 nines durability, that is 99.999999% durability. That too with a good availability of 99.99% and high scalability feature also. Let's discuss some advantages of S3. At first, scalability. Amazon S3 is highly scalable, where you can add more number of buckets if required, and in a single bucket you can add more data also. And Amazon S3 charges you only for what you actually use. And here there are no hidden fee charges also. This service allows you to scale your storage resources up and down so that you can meet fluctuating demands as per your business requirements when you need them. Second, durability and accessibility. Amazon S3 has a durability of 11 nines, which means if you store 100 billion objects in S3, you will lose one object at most. Third, cost effective. When you use Amazon S3, you can store your data in a range of storage classes based on how frequently and immediately you need to access those files, where this ranges from most expensive level where you access your mission critical files immediately to the lowest cost level, which is for files you rarely touch. At 4, security. Data stored in your S3 environment is protected from unauthorized access due to encryption features and access management tools provided by AWS. The two which includes blocking all public access from all of your objects, not just at the bucket level but also at the account level also. Versioning. In S3 bucket, versioning is not enabled by default, and in S3 versioning allows us to store multiple variants of a file or object to exist in the same bucket. So this provides an opportunity to roll back or recover if an object is deleted. Finally, disaster recovery. S3 storage makes it easy to protect critical applications, data, and IT systems. It offers recovery from outages no matter if they are caused by system failures, natural disasters, or human error. Buckets. In S3, if we want to store objects, for that we need to have a place to hang out, and that place we call it as a bucket. And here you can see the icon of a bucket. A bucket is a container to store objects like files, videos, pictures, and we can upload multiple objects to a single bucket. Here there is no limit on the number of objects you can store in a single bucket. AWS allows us to create up to 100 buckets in each of AWS accounts, and if we want more buckets we can request up to a maximum quota of 1000 by submitting a service limit increase. Whenever we create a bucket, we need to select a region to where it should be stored, and we need to give a bucket name also. And here S3 bucket name is globally unique, and that means the namespace is shared by all AWS accounts. This means that after a bucket is created, the name of that bucket cannot be used by another AWS account in any AWS region until the bucket is deleted. Accessing a bucket. We can access the bucket using S3 console UI with two types of URLs. One is virtual hosted style access and other is path style access. Virtual hosted style access. Let's see both. In virtual style URL, we need to specify bucket name followed by S3 service and region name. But here region name is optional. Path style access. In path style URL, we will mention region name at first followed by S3 service and bucket name is mentioned at the end. Objects. As we have discussed in previous slides, that S3 will store multiple objects in a single bucket. And here in Amazon S3 terms, an object is a data file where its metadata included and where these objects could be documents, photos, videos and more with any file type. Here each object is also given an ID number and applications use this ID number to access objects. And here objects consist of keys which refer to the name of the object. Then value. It is the data being stored in bucket and is made up of sequence of bytes. And then here version ID will come when we enable versioning for a bucket and Amazon S3 automatically generates a unique version ID for the object being stored where the ID number is the combination of numbers. Consistency model. Let's see the working nature of data consistency model to S3. Basically S3 has two things. It has read after write consistency for puts of new object and then it has eventual consistency for overwrite puts and deletes. Now you will be thinking, what does that mean? Well, the first one, read after write consistency for puts of new objects. All that means is if you upload a file to S3, you are able to read it immediately, so you are able to read it straight after writing to it. And that is basically you are just doing a put of that object into S3. Now if you get into and basically update that object or delete that object, so overwrite that object, then it's only going to be eventual consistency. So let's say we have got version 1 of file and then upload version 2 and immediately try and read that object. Here basically what is going to happen is you might get version 1 or you might get version 2, but if you wait for seconds you're always gonna get version 2. So there is eventual consistency for overwrite puts and deletes. So when you are overwriting a file or deleting a file, then eventually it's going to be consistent. So these are the basics of S3 we discussed, and see you in the next lecture. Hello everyone, welcome to this lecture. In this lecture, I'm going to discuss about S3 storage classes. Totally we have 6 types of storage classes and they are S3 Standard, Intelligent Tiering, Standard IA, One Zone IA, Glacier and Glacier Deep Archive. First, let's discuss why storage classes are important. When we upload an object into bucket, that object goes on with various changes and finally it will show in bucket. And that changes will be like if we want our object should store in multiple availability zones or multiple servers with minimum storage duration like 30 days, 60 days, 90 days and 180 days. And based on selection of storage classes, that cost effect also will get changed. And here storage classes will work on lifecycle management. So data will be migrated from one to another for cost savings. Let's discuss each storage classes. At first, S3 Standard. This is the one with 99.99% availability and 11 nines durability. And it stores redundant across multiple devices in multiple facilities and is designed to sustain the loss of two facilities concurrently. S3 Standard is a general purpose storage class and it will have frequently accessed data where that data should be retrieved very quickly. By adding a lifecycle wall to a bucket, you are able to configure and set specific criteria that can automatically move your data from one class to another or delete it from Amazon S3 altogether. We will do this as a cost saving exercise by moving data to a cheaper storage class after a set period of time. S3 Intelligent Tiering. This storage class is ideal for the circumstances where the frequency of access to the object is unknown. Effectively, if we have unpredictable data access patterns, and so by using this storage class, it can help to optimize our storage costs. When the objects are moved to intelligent tiering, they are placed within the frequent access tier, which is somewhat if an object is not accessed for 30 days, and then AWS will automatically move the object to the cheaper tier known as infrequent access tier. Once that same object is accessed again, it will automatically be moved back to the frequent tier. Much like S3 standard, S3 intelligent tiering also offers 11 nines of durability across multiple availability zones, offering protection against the loss of a single availability zone. However, its availability SLA is not quite as high as S3 standard, as it's set at 99.9% availability. S3 standard infrequent access. This can be seen as the equivalent to the infrequent tier from the intelligent tiering class, as it is designed for data that does not need to be accessed as frequently as data within the standard tier, but it still offers high throughput and low latency access. Same as S3 standard, does it carries that 11 nines durability across multiple availability zones and with 99.99% availability. S3 one zone infrequent access. S3 one zone IA is for data that is accessed less frequently but requires rapid access when needed. Being an infrequent access storage class, it is designed for objects that are unlikely to be accessed frequently, where it carries the same throughput and low latency with the good durability at 11 nines across a single availability zone and with 99.95% availability. As the name implies to this class, it is one zone, as in one availability zone. So the objects will be copied multiple times to different storage locations within the same availability zone instead of across multiple availability zones. S3 Glacier. Glacier storage class is suitable for low-cost data archiving where data accessed is infrequently and where retrieval time will be between minutes to hours. And this class has a minimum storage duration period of 90 days and uses the very low-cost Glacier storage service. And the objects in this storage class are still managed through S3, but it doesn't provide you the same features as Amazon S3. And more importantly, it doesn't provide you instant access to your data. However, S3 Glacier does offer a variety of retrieval options depending on how urgently we need the data back, each offering a different price point. These being expedited, standard, and bulk. Expedited. This is used when we have an urgent requirement to retrieve our data, but the request has to be less than 250 megabytes. The data is then made available to you in 1 to 5 minutes, and this is the most expensive retrieval option of the three. At second, standard. This can be used to retrieve any of your archives, no matter their size, but your data will be available in 3 to 5 hours, so much longer than the expedited option, and this is the second most expensive of the three options. And finally, bulk. This option is used to retrieve petabytes of data at a time. However, this typically takes between 5 to 12 hours to get completed. This is the cheapest of the retrieval options, so it really depends on how much data and how quickly you need it. So, as the retrieval speed and cost to be made by your retrieval option. S3 Glacier Deep Archive. Out of all the storage classes offered by S3, Glacier Deep Archive is the cheapest and it is mainly focused on long-term storage. This is an ideal storage class for circumstances that require specific data retention regulations and compliance with minimal access. The durability and availability matches that of S3 Glacier with 11 nines durability across multiple availability zones with 99.9% availability. So this is the detailed explanation of storage classes we have discussed, and see you in the next lecture. Hello everyone, welcome to this lab on buckets and objects. In this lab we are going to create buckets and upload objects into it, and also we discuss some features of S3 bucket here. And here is the AWS management console. If we have recently visited any AWS services, we can see those services in recently visited list here, or else we can search for particular service in search bar here, and let's type S3. Okay, here are the search results for S3, and now let's click on S3 service. So this is the brand new S3 console of AWS, and as we don't have any buckets created here, it will show as no buckets created. So let's go ahead and create our first bucket. Here click on create bucket, and here we need to give bucket name that is unique globally across all AWS accounts, and let's give bucket name as my bucket lab. Okay, now next we need to select region. Click on the button here and you can see the list of regions available. And here one important note is that S3 doesn't belong to any particular region. And here you can see S3 does not require region selection, but a bucket should be placed in a region. And here now let's select the region as US East 1 only. And here we can see other option, that is choose bucket. If we click on this, it will show the previously created buckets, and from this list we can select a bucket to copy settings. And one important note is this feature is optional. And we have other settings like bucket settings for public access, and we are going to have a lab session for public access settings and about versioning and encryption in commencing labs. So let's skip these settings now. Okay, and now let's go ahead and create our first bucket. Okay, now our bucket is created successfully, and you can see a pop-up that successfully created. So let's go into bucket and upload some objects into it. Click on upload option here, and now let's add some files into it by clicking on add files here. Now here we can see the destination as our bucket name and other properties as disabled like versioning, encryption and object lock. Okay, now let's click on upload here to upload the files. Okay, now our objects are uploaded successfully. And here we can see object details like type of file, when it was uploaded, size and storage class. And while uploading object, we haven't selected any storage class, but it will take standard storage class as default. Now if we want to open file, we can navigate to object options here by selecting an object and click on options here and click on open, and it will open the object in the next tab. Or else we can directly go into the object by clicking on it, and here navigate into the object options here and click on open. Another way to access the file is by copying the object URL of this one, and let's paste into this into another tab. Okay, but we are receiving error as access denied because we are using public based URL, and which is our S3 bucket is not public. And if we use this URL, we can access a file because it is a pre-signed URL. Okay, now let's add another file into a bucket, but this time we upload a file into a folder. Okay, let's create a folder now. Okay, click on the image folder here and click on upload files. And finally click on upload. Okay, now we have uploaded objects directly into a bucket and to a folder. Okay, now let's see some features available in Objects Resource tab here. Here in the Objects tab, we can upload files by clicking on Upload and create a folder to add specific files separately, or else we can perform some actions for already created files and folders. Okay, and here if we do drop down of actions here, we get some more options. Like if we click on Open, it will open object in a new tab. And here we have other option, that is calculate total size. If we select this one, it will show the size of object, or else we can calculate total size of objects. Now let's select one object and click on calculate total size. And now it is showing only 66.7 KB for one object. Now let's select all objects and let's click on calculate total size. Okay, now it is showing the total size of 5 objects like 146 KB. Okay, and next copy option will copy object and paste it in other folder without removing it in original location. And then move option. This move option will move the objects into a folder by removing it in original location. And next we have download options. Download option will download the object into our local desktop and then we can access it. And finally we have edit options, where we can edit name of object or change storage class from standard storage class to OneZone IA or standard IA or any other storage class like Glacier. And also we can change encryption from server side to client side. And also we can edit metadata or tags, or we can make the objects into a public. Okay, and that's the end of this lab session, and see you in the next lecture. Hello everyone, welcome to this lecture on S3 bucket and user policies. What are bucket and user policies? Bucket and user policies are policies that are defined in JSON format and which will be used to grant access on buckets and objects. Here JSON stands for JavaScript Object Notation, and it is basically a way of defining data. Here bucket policies are resource based, which mean the policies themselves are attached to resource in case of S3 bucket. And bucket policies are also called as sub-resource, which mean they don't exist independently, that actually assigned to resource. And here the resource is bucket. If the bucket gets removed, then policy also gets disappeared. And user policies are user based and are managed in IAM. Here neither of these policies are applied by default, and when we create an object in bucket, we get a default access control list, but we won't get bucket or user policy. Let's see some features. Bucket policies can be used to grant permissions to AWS accounts and also to IAM users with very fine-grained level. It can explicitly deny access and can grant conditional permissions. And here bucket policies are limited to 20 KB size, that to declared in JSON format. A policy contains following elements, like we have resources, the bucket or object for which the access applies to, and this is specified as Amazon resource number. Here we use ARN to identify the resource. Actions, the list of permissions to allow or deny, and in actions for each resource, Amazon S3 supports a set of operations. Effect, the effect taken when the user requests the action like either allow or deny. Here, if we do not explicitly grant access to a resource, access is implicitly denied. And also, we can explicitly deny access to a resource. Principal, the account or user that is allowed access to the actions and resources specified in the statement. Here in a bucket policy, the principal is the user, account, service or other entity that is the recipient of this permission. And finally, condition. These are optional policy element. that allow us to specify conditions for when a policy is in place. Here we can use AWS wide keys and Amazon S3 specific keys to specify conditions in an Amazon S3 access policy. And that's the end of this lecture about bucket and user policies. And see you in the next lecture. Hello everyone. Welcome to this lab on S3 bucket policies. Here we are in S3 console now. And let's navigate to permissions to one of the bucket here. And the goal for us is to define a bucket policy that we will be writing in JSON. And this policy is going to prevent the putting objects that are not encrypted. So let's edit this bucket policy. And here we have two links. One is policy examples. This will directly goes to documentation of AWS. Here it will show all kind of examples and possibilities. Another is policies generator. So let's generate our bucket policy. First, we need to select the policy type and select the S3 bucket policy. So let's select the S3 bucket policy and let's add some statements here. So what we'll do here is to deny any objects being uploaded into Amazon S3 as free that are not encrypted using keys. So we are going to have the effect to be deny. Principles are from everywhere and give it as star. And in the drop down of actions, select the put object. Here it is. And then we need to specify the ARN. So the ARN should be the bucket name / key name. Here we have copy it and paste it here. And lastly, make sure to add / and then star at the end of the resource name here. Now let's add a condition. In the condition field, select null and the key is going to be S3XAMZ server side encryption. Here it is. And the value is true. And finally click on add statement. Now we will do a second statement. So let's repeat the same. Now coming to condition, this time we will select string not equals. And the key is same one before we have selected. And the value should be AES256. Now copy the policy and paste it in S3 console. Click on Save Changes. So, we have defined a bucket policy which denies an object being encrypted if it's not encrypted with SSE S3. So, let's test it now by uploading an object. Okay, it failed, and we can look why it is failed. So, it failed as access denied, and this is due to bucket policy. So, it's working as expected. Now, let's try to upload the same file. But this time, we will specify the encryption to be SSE S3. Yes, this time it's successful. Let's try to upload the same file again. But this time let's see with KMS by overriding it. And click on upload. So it's failed again, showing access denied because of bucket policy. So that's the end of this lecture, and see you in the next. Hello everyone, welcome to this lecture. In this lecture, I'm going to discuss about S3 access logging. So let's first begin what exactly access logging is. Amazon S3 access logging information is useful for security and audit purpose. Here, S3 bucket access logging captures information on all requests made to a bucket, such as put, get, and delete actions. So, S3 access logging basically tracks requests for access to a bucket, and it records information that is useful for tracking. This means it captures information on all requests made to a bucket. Here, bucket access logging is disabled by default, and no charge to enable it, but charged for log storage. However, any log files that the system delivers to your bucket accrue the usual charges for storage, and we can delete these log files at any time. Server access logging provides detailed records for the requests that are made to a bucket, and these access logs are useful for security and access audits. It can also help us to understand our Amazon S3 bill. Let's see the access logging terminology. Here we have source bucket. It is a bucket that we want to log, and then a target bucket to where logs will get stored. And finally, access logs, which records information made on our bucket like put, get, and delete actions. Let's see the flow of logs. Once the user made a request of put object into a S3 bucket, and now S3 monitors that request and it writes logs to target bucket. How logs are delivered. S3 periodically collect access log records to consolidate them, and then it upload log files in batches to our target bucket. If you enable logging on multiple source buckets and one target bucket, then target bucket will have access logs of all those source buckets, but each log object reports access log records for a specific source bucket. To write access logs here, Amazon S3 uses a special log delivery account called log delivery group, and these writes are subject to the usual access control restrictions. Here we must grant the log delivery group with write permission on the target bucket by adding a grant entry in the bucket's access control list. So this is the explanation of S3 access logging, and see you in the next lecture. Hello everyone, welcome to this lab on S3 access logging. In this lab, we will set up access logging on our S3 bucket. And to this, we create a dedicated target bucket to store the access logs. And here we an S3 console. So I already have created a target bucket with the naming as my bucket lab access logs 1.1. So now let's enable access logging on source bucket. So whatever the logs that are getting generated from source bucket will directly go to destination bucket. Go to the properties tab here and do scroll down. Yes, here we have server access logging option. Click on edit here to enable. Click on enable option, and here we need to select the target bucket. Select the target bucket as my bucket lab access logs 1.1, and here give the prefix as source bucket name so we can easily identify the logs belong to which bucket. Why? Because to the same destination bucket we can enable logs from multiple source bucket. Click on save changes. Okay, now let's upload some objects. So this will generate some traffic onto my bucket. Click on upload. Okay, files have been successfully uploaded. Now let's see our target bucket. Okay, here under objects it is empty. Why? Because it will take some time to get logs written here. But one question will get like, how does this bucket just by turning on the server access logging will get the permission to write to my logging bucket? Let's go to source bucket here. Yes, and here it is under access control list. And so it says here, by enabling server access logging, S3 console will automatically update your bucket access control list to include access to the S3 log delivery group. Here you can see it is. So let's check this. Now let's go to our access log bucket under permission. If I scroll down and we get access control list or not. Yes, here I can see the S3 log delivery group with write permission for objects and read permission for bucket access control list. And this automatically enabled by Amazon S3 when I enable server access logging. As it takes some time to get logs written here, we just look into another S3 bucket which I already have created for access logging. My Bucket Lab access logs, which I already have created it before. Click on this. And here you can see three prefixes right. Why? Because as I said earlier, the one target bucket can get logs from multiple source bucket. So when log traffic is happening from multiple source bucket to single target bucket, it's better to give the prefix name as source bucket name. So in target bucket, we can easily identify the logs belong to specific source bucket. Now let's click on any folder here. Let's see the logs of each one. I have downloaded it and open this text file of the log. Here this is the request ID and the bucket it was made on. And next, time and date of the bucket request. And here you can see the bucket name, that is source bucket name, that is my bucket lab 1.1, and it is showing the IP address from where it came, and also it will show the unique request ID. This is the one, and this is the operation that REST request gets. Here you can see the logging status also. And here it is showing the 200, that is HTTP status, which means exceeded. And this is the time taken in milliseconds to complete the request. And this is the processing time, that is 14 here. So it is the time taken by S3 to process our request. So that's it for access logs. I hope you liked it, and I will see you in the next lecture. Hello everyone, welcome to this lecture on S3 encryption. Let's take a look on what exactly is S3 encryption. S3 encryption refers to the protection of data either while in transit, this means as it travels to and from Amazon S3, and also at rest while it is stored on disks in Amazon S3 data centers. By default, data stored in an S3 bucket is not encrypted, but we can configure the AWS S3 encryption settings. And here we can set default encryption on a bucket so that all new objects are encrypted when they are stored in the bucket. Here we can protect data in transit using secure socket layer or transport layer security or client-side encryption. Here we have two options for protecting data at rest in Amazon S3. One is server-side encryption and other is client-side encryption. Let's discuss server-side encryption. Amazon S3 to encrypt your object before saving it on disks in its data centers and then decrypt it when you download the objects. Server-side encryption is the encryption of data at its destination by the application or service that receives it. Here, Amazon S3 encrypts your data at the object level as it writes it to disks in its data centers and decrypts it for you when you access it. Here, important note is that we can't apply different types of server-side encryption to the same object simultaneously. Here, we have three types of server-side encryption options. Server-side encryption with Amazon S3 managed keys. Next, server-side encryption with customer master keys stored in AWS key management service. And at last, server-side encryption with customer provided keys. Let's see client-side encryption. Client-side encryption is the act of encrypting data before sending it to Amazon S3. To enable client-side encryption, we have two options available. One is use a master key stored in AWS key management service. And second is use a master key that is stored within your application. And that's the end of this lecture, and see you in the next. Hello everyone, welcome to this lab on S3 encryption. Here we are in S3 console now. And first let's see the navigation to encryption setting. Click on object here and in properties tab here just scroll down. Yes, here we have encryption setting, that is default encryption as disabled and server-side encryption as none. As encryption is disabled, here this means our object is not encrypted. Now we could edit it and encrypt it in place, but we'll see how to do it and as well when upload a file. So let's go ahead and upload an object. Do scroll down and here we have options, that is additional upload options. Do scroll down of this. Yes, and here we have different kind of options. One is Amazon S3 key and other is AWS key management service. So the first encryption type we are setting here is Amazon S3 key, and in this case also we using Amazon S3 key, and this is an encryption key that Amazon S3 will create, manage and use for us. Now we could just go ahead and create that file, for example with Amazon S3 key. So we have successfully uploaded the file with encryption of Amazon S3 key. Let's cross check this in configuration tab here. Yes, it's successful with encryption of Amazon S3 master key. Okay, now let's do it again by uploading the same object. And this time the file is protected by AWS key management service key. And here we have couple of options. One is AWS key managed service, or we can choose our own KMS master keys by creating it, or if the key isn't in other accounts we could enter the KMS master key ARN manually here. So for now we are going with AWS key management option. So let's go ahead and upload a file. Okay, file successfully uploaded with AWS KMS encryption. Now let's see the encryptions for all versions of objects. Click on list versions here. This is the file that I have uploaded at first, and let's see this. Okay, to this encryption is none. Now let's see second uploaded object. Okay, this version is enabled with Amazon S3 master key. Now finally, let's see recently uploaded object. Okay, this version is enabled with AWS KMS master key option. So what this means is encryption setting is just for a specific file and its specific version ID. So we can have encryption enabled for a specific file while uploading the object, or we can enable the encryption on the bucket level also. So let's navigate to that. Here we have default encryption that is disabled. Click on edit to enable it. Click on enable option, and here we are going to select with the Amazon S3 key. Okay, if we select Amazon S3 key, then by default every single object is uploaded with encryption key. So let's use this now and save changes. Okay, now let's upload a file without enabling encryption while uploading it. And here it's showing server-side encryption is already enabled. And two other options, one is use default encryption bucket settings and other is override default encryption bucket settings. So let's go with default and upload a file. Okay, now let's check the object uploaded. Yes, it has Amazon S3 master key. So default encryption setting worked properly. That's the end of this lab on encryption, and see you in the next lecture. Hello everyone, welcome to this lecture. In this lecture, I am going to discuss about S3 versioning and MFA delete. Let's discuss about versioning. What is S3 versioning? Versioning is the ability to keep multiple versions of same object or a file in the same bucket. It keeps the multiple forms of an object in the same S3 bucket and where it will be used to retrieve, preserve and restore every version of an object in S3 bucket. As versioning maintains multiple copies of the same object and charges accrue for multiple versions. For example, for a 1 GB file with 5 copies with minor differences would consume 5 GB of S3 storage space and you would be charged for the same. And here, versioning is not enabled by default. It has to be explicitly enabled for each bucket. And that too, once versioning is enabled, cannot be disabled and can only be suspended. Once the versioning state is enabled, all the objects in a bucket will remain versioned and they are provided with the unique version ID. MFA delete. MFA delete is a multi-factor authentication delete that provides an extra layer of protection to ensure that the S3 objects cannot be accidentally or intentionally deleted by the AWS users who have access to the buckets. MFA delete requires two forms of authentication and they are our security credentials and the concatenation of a valid serial number, a space and the 6-digit code displayed on a approved authentication device. And to use MFA delete, we can use either a hardware or virtual MFA device to generate an authentication code. Here is the example which shows a generated authentication code displayed on a hardware device. Object addition. For non-version bucket, if an object with the same key is uploaded again, it overwrites the object. And for version bucket, if an object with the same key is uploaded, the new upload object becomes the current version and the previous object becomes the non-current version. So a non-current version object can be retrieved and restored, hence protecting against accidental override. Object deletion. For non-version bucket, an object is permanently deleted and cannot be recovered. And for version bucket, all versions remain in the bucket and Amazon inserts a delete marker which becomes the current version. So a non-current version object can be retrieved and restored, hence protecting against accidental overrides. If an object with a specific version ID is deleted, a permanent deletion happens and the object cannot be recovered. Object retrieval. For a non-version bucket, an object retrieval always returns the only object available. And for version bucket, an object retrieval returns the current object and non-current object can be retrieved by specifying the version ID. Versioning suspended bucket. Versioning can be suspended to stop occurring new versions of the same object in a bucket, and existing objects in the bucket do not change, and only future requests behavior changes. For each new object addition, a object with version ID null is added, and for each object addition with the same key name, the object with the version ID null is overwritten. An object retrieval request will always return the current version of the object. And here are some of the points that we need to remember. A delete request on the bucket would permanently delete the version ID null object and inserts a delete marker. A delete request does not delete anything if the bucket does not have an object with version ID null. And at last, a delete request can still be fired with a specific version ID for any previous object with version ID stored. So this is the explanation of versioning and MFA delete, and see you in the next lecture. Hello everyone, welcome to this lab on S3 versioning. In this lab, we are going to see on non-versioning, version enabled and version suspended bucket. And now we are in S3 console. Okay, I already have created a bucket naming my bucket lab version 1.1, but versioning is not enabled to this bucket. Now to this bucket, let's upload some files and test it. Let's go into the bucket, click on upload, click on add files, and select the text document here. Okay, we can see our object is uploaded successfully. Now click on object and let's see version properties. Navigate to versions here. And here you can see the prompt that versioning is not enabled on bucket. And down can see the version ID as null and last modified time also. And now let's upload the same file and see what will happen to previous file. Here you can see we have only one object available but with last modified time as 1140 UTC time. This means in non-version bucket, if we upload same file name object multiple times into a bucket, it will have only one object get stored to that. Okay, now let's enable versioning on a bucket and see what will happen if we upload same object multiple times. To enable versioning, navigate to properties here, and here you can see bucket versioning which is disabled. Click on edit. Here you can see options available like suspend and enable versioning. Here one important note is once versioning is enabled, we can't disable it and only it can be suspended. Now select enable and click on save changes here. Okay, now let's upload the updated file here. Okay, now to see versions of our uploaded file, click on list versions here. Or else you can click on any object version of this and navigate to version resource tab. Let's click on text and navigate to versions properties here. And here you can see the list of versions available with version ID as null and with version ID as the number. And this is the current version. and you can navigate to other version from here only by clicking on this. Okay, now let's download the version 1 of this file and upload it again, and we'll see what will happen. Okay, now we have uploaded the same object file which is downloaded. Now let's click on this text and let's open it. Okay, it is version 1 file. This means if we upload the same version file which is downloaded and uploaded, it will get saved and all previous versions also will be available with lost modified time. And here you can see the lost modified time available in the UTC format. Okay, now let's see what will happen if we suspend versioning. To suspend versioning, navigate to Bucket Properties tab and here click on Edit and select Suspend, and finally click on Save Changes. And before to this, acknowledge that I acknowledge the outcomes of suspend versioning bucket. Okay, now we have suspended the versioning, and let's upload some files and we'll see what will happen. Okay, after versioning is suspended on the bucket, we have uploaded the text document and we can see the version ID as null. This means after suspending versioning on the bucket, the newly uploaded object version is saved to non-versioned object. And here you can see the differences for version IDs. For version enabled buckets we have ID and non-version we have null. Okay, in this lecture we have seen differences of non-version, version enabled and suspend versioning buckets. Okay, and that's the end of this S3 versioning lab, and see you in the next. Hello everyone, welcome to this lab on MFA delete. Here we are in S3 console now, and let's create a new bucket for MFA delete lab. Okay, our bucket is successfully created, and now let's go into the bucket. Click on Properties tab here and enable versioning by clicking Edit here. And here you can see that multi-factor authentication delete is currently disabled, and we cannot change this through GUI of Amazon console, but we can enable it using AWS CLI. Before configuring MFA delete now, let's go to My Security Credentials. And click on Multi-Factor Authentication, that is MFA. Here you can see I have set up already a virtual device for my MFA, and the ARN is right here. Okay, For configuring AWS CLI in our laptop, now let's create access keys and download them. Click on Create Access Key and download the key file. Now we will do set up our CLI with these two access keys. Now open command prompt. Okay, it's working. Now let's do configuration part. And name it as root mfa delete demo. Now give access key ID. And secret access key also. And give the region name as US East 1. And default output format. Okay, now let's execute one command as a check readiness, that is AWS S3LS. Okay, it's perfect. Now let's enable MFA delete by executing the command, that is the first one. Here make sure that bucket name is correct. And give profile name as root MFA delete demo. And here we need to provide the authentication number. And here we need to provide the ARN. Okay, it's successful. Now let's verify whether MFA delete is enabled or not. Now navigate to that MFA bucket. Yes, here you can see that multi-factor authentication MFA delete is enabled. Okay, upload any object into bucket now. Okay, file is uploaded successfully. Now let's delete this object now and give confirmation delete text. Okay, object is deleted. Now go to main page of object and list versions. Okay, here I have two versions of file which I have deleted. For example, select this object and try to delete this specific version. Okay, here I have two versions of files which I have deleted. For example, select this object and let's try to delete it. Okay, and it says you can't delete object versions because multi-factor authentication delete is enabled for this bucket. So to do this, we need to use CLI command to delete this file or else disable MFA delete. Okay, copy this command. Now let's try to disable the MFA delete. Okay, command executed successfully. Now let's go to bucket properties tab and check the MFA delete here. Okay, now it is showing that MFA delete is disabled. Now let's try to delete the object. Okay, our object is deleted successfully now. Okay, that's the end of this lab on MFA delete and see you in the next lecture. Hello everyone, welcome to this lecture. In this lecture, I am going to discuss about cross-region replication. Okay, what is cross-region replication? Cross-region replication is a feature that replicates the data from one bucket to another bucket, which could be in a different region, which provides asynchronous copying of objects across buckets. And here, destination buckets can be in different AWS regions or within the same region as the source bucket. To enable object replication, we need to add a replication configuration to our source bucket, and here are the minimum configuration requirements must include. At first, the destination bucket or buckets where you want Amazon S3 to replicate objects, and at second, an AWS identity and access management role that Amazon S3 can assume to replicate objects on your behalf. Let's see some use cases of cross-region replication. At first, compliance. By default, Amazon S3 stores the data across different geographical regions or availability zones to have the availability of data. Sometimes there could be compliance requirements that you want to store the data in some specific region, and cross-region replication always allows you to replicate the data at some specific region to satisfy the requirements. Second, latency. If two users are in two different locations of the world, objects required by them can be accessed much more quickly by storing copies of the objects closer to the respective users' locations. At last, maintain object copies under different ownership. Regardless of who owns the source bucket, you can tell to Amazon S3 to change the ownership to AWS account user that owns the destination bucket, and this is referred to as an owner override option. Features of cross-region replication. It helps seamlessly copy object from an S3 bucket in a specific location to another location's S3 bucket, and it can be implemented only when both buckets have their versioning feature enabled. And when an object is being copied from one bucket to another bucket, here data is encrypted with the help of SSL so as to protect it from attacks. And here, if data which is being copied from source bucket is already present in the destination bucket, the data doesn't get replicated even if the operation is performed, and this way the redundant data is not stored. Here are some points to be remembered for cross-region replication. At first, create two buckets. Create two buckets within AWS Management Console. Here where one bucket is a source bucket and other is a destination bucket. Second, enable versioning. Cross-region replication can be implemented only when the versioning of both the buckets are enabled. Third, Amazon S3 encrypts the data in transit across AWS regions using SSL. It also provides security when data is transferring across different regions. And finally, already uploaded objects will not be replicated. If any kind of data already exists in the bucket, then that data will not be replicated when you perform the cross-region replication. So this is the detailed explanation of cross-region replication, and see you in the next lecture. Hello everyone, welcome to this lab on cross-region replication. In this lab, we are going to replicate data from source bucket of one region to target bucket which is in another region. And here we are in S3 console now. So let's create a new bucket naming my bucket lab replicate 1.1. Click on create bucket. Okay, and now our bucket is created successfully. Here we let's use my bucket lab 1.1 as source bucket and my bucket lab replicate 1.1 as destination bucket. This means we replicate everything from source bucket to destination bucket. Here, one important note is if we want to use replication, we should have versioning enabled in both buckets. So now let's enable versioning on both buckets. Let's go into my bucket lab 1.1, that is source bucket. Navigate to properties, click on edit and select enable. Now let's navigate to destination bucket, that is replicate. Navigate to properties, click on edit here and select enable, and finally click on save changes. Okay, now versioning is enabled on both buckets. Okay, now to enable cross-region replication on source bucket, click on bucket and navigate to management resource tab here. And here click on create replication rule. Provide replication rule name as my data replication and select status as enabled. Down you can see the source bucket details, and here we have two options available. One is limit the scope of this rule using one or more filters. This means we use this to replicate particular folder or prefix. And second option is this rule applies to all objects in the bucket. This means if we use this, it will replicate the whole bucket. And now let's select this rule to all objects in the bucket, that is second option. Now let's select the destination bucket. Here we can select a bucket of same account or a bucket from another account. Browse S3 and select the bucket as my bucket lab replicate 1.1 and click on choose path. And then we select IAM role. We select this role because S3 needs permission to perform replication. So let's go ahead and create a new role. Click on create new role. Now we need to select destination storage class. If we do not select this box, it will take standard storage class as default. So now let's select other storage class like OneZone IA. And finally click on save here. Okay, now we have versioning enabled and replication enabled in source bucket. Here one important note is that replication is performed for only newer objects that are uploaded after enable replication. Okay, now let's upload some files into source bucket and see what will happen. click on upload here, add files. Now let's see the destination bucket. Navigate to destination bucket here, that is replicate 1.1. Refresh the bucket. Okay, we got objects replicated from source bucket to here. Now let's upload another file, that is text. Now let's update the text document and let's upload the file. Now we have uploaded the updated text file and we have list versions also here. You can see. Now let's navigate to destination bucket and refresh it. Now click on list versions here. Now click on list versions here. Yes, and now we got versioned objects also replicated. Now let's delete an object in source bucket and we'll see whether it will get replicated or not. Navigate to source bucket in the S3 console. Click on source bucket here. Now let's delete an object. Okay, we have deleted image name object. Let's refresh the destination bucket and see. Okay, we have image object available in destination bucket. This means when you delete a specific object in source bucket, that is not replicated to the destination bucket. And this is why, because S3 will protect our data even after the intentional deletion or accidental deletion is happened. So if your object got deleted in source bucket, then you can restore it from destination bucket. Okay, that's the end of this lab on cross-region replication, and see you in the next. Hello everyone, welcome to this lecture. Here we are going to discuss about S3 lifecycle management. What is lifecycle management? Lifecycle management will do transitioning and controlling of objects from one S3 storage class to another storage class. Here it will also do archive and delete them after a specific period of time. And lifecycle configuration contains set of rules that define the actions applied to S3 by a group of objects. Lifecycle management can be configured with versioning, which allows storage of one current object version and 0 or more non-current object versions. And here, objects lifecycle management applies to both non-versioning and versioning enabled buckets. Let's take an example. When we have that objects are infrequently accessed, by using lifecycle rules, we can transit them to S3 standard IA storage class. And also we can archive objects that we don't need to access them in real time to the S3 Glacier storage class. The lifecycle defines two types of actions. One is transition action. This action defines the transition of objects from one storage class to another storage class. For example, you choose to transit the objects to standard IA class 30 days after you have created them, or archive the objects to the Glacier storage class 60 days after you have created them. And second is expiration actions. This action defines the expiration of objects. This means Amazon S3 deletes expired objects automatically. In terms of features, it will switch objects between different storage classes in order to reduce cost. It can automatically expire objects after a specified period of time. We can enable up to 1000 lifecycle rules per bucket. And also we can apply the rules to whole bucket or all objects in a bucket which follow the same rule, or also to a subset of objects. Objects lifecycle management applies to both non-versioning and versioning enabled buckets. Here is a waterfall model for transition between storage classes. Here transition will happen from S3 standard storage class to any other storage class. And second, any storage class to S3 Glacier or S3 Glacier Deep Archive storage classes. Intelligent tiering storage class to one zone IA storage class. And finally, S3 Glacier storage class to the S3 Glacier Deep Archive storage class. Here are the supported lifecycle transitions that we have discussed in previous slide. Like supported lifecycle transitions, we also have unsupported lifecycle transitions. This means the transition will not happen backwards. Any storage class to S3 standard storage class, any storage class to reduced redundancy storage class, S3 intelligent tiering storage class to S3 standard IA storage class, and finally from one zone IA storage class to standard IA or S3 intelligent tiering storage class. Okay, that's the end of this lecture on lifecycle management, and see you in the next lecture. Hello everyone, welcome to this lab on lifecycle management. In this lab, we are gonna set up lifecycle rules on a bucket. And here we are in S3 console now. Let's use this version enable bucket, that is my bucket lab 1.1, to enable lifecycle rule. To enable lifecycle rules, just click on a bucket and navigate to Management Resource tab. And then click on Create Lifecycle Rules here. And provide a lifecycle rule name. And I will give name as my bucket lab LC rule. And here we can either apply it to a specific scope with one or more filters, or else we can apply it to a whole bucket. Now let's go with the whole bucket scope. Okay, here we have 5 different kind of lifecycle rule actions. Here we can transit current versions of objects between storage classes, and also we can transit previous versions of objects. Here current and previous versions means if we have objects uploaded into bucket before versioning is enabled, and those we call it as previous versions. And current version mean the most recent version if we have enabled versioning. And also we can expect current versions of objects and permanently delete versions of objects. And finally delete expired delete markers or incomplete multi-part uploads. And for now, let's select transit current versions of objects between storage classes. Now we need to select a different storage class for transition And here we can see different storage classes available. Click on the drop down here. And here you can see standard IA, intelligent tiering, one zone IA, glacier and deep archive. And here we select standard IA as default. And now let's give 30 days after object creation. Click on add transition here. And then we can move the objects to intelligent tiering after 90 days. And then click add transition and select one zone IA for 150 days. Instead of one zone IA, let's give glacier. And then select glacier deep archive finally for 270 days. And here it is giving a warning that transitioning small objects to glacier or glacier deep archive will increase costs. This means don't transit unnecessary objects which are smaller to glacier or glacier deep archive. Just transit the objects which are more important and larger files only. Just acknowledge it. And here you can see the lifecycle transition summary that we have created. The object will transit to standard IA after 30 days of object creation, and then to intelligent tiering after 90 days, and then to glacier after day 150, and finally to deep archive after 270 days. And in parallel to this lifecycle action, we can add other lifecycle action also. So let's select transition previous versions of objects. And here let's select glacier storage class for 90 days. Let's acknowledge the warning here. And also let's select expire current versions of objects. And here we provide the value that number of days object creation, and I'm giving 455 days here. This means it will expire objects after 455 days of object creation. So now let's see the updated timeline summary. And here under current version actions we got day 455 object expire. This means objects will get deleted automatically after day 455. And we got previous version actions also. Here after 90 days we'll transit to glacier. So let's go ahead and create a rule. Okay, and now our lifecycle rule created successfully. Okay, now select the lifecycle rule here and click on view details. Here it will show the details of our lifecycle rule with status enabled or disabled, scope and transition summary. And here only we can do disable the rule by giving click on this. Navigate to actions and click on disable rule. We can do edit this rule like making changes in lifecycle actions by selecting other or removing one. Or else we can do edit the days after object creation values also and click on save finally. Okay, that's the end of this lab on lifecycle management, and see you in the next. Hello everyone and welcome to this lecture where we are going to be talking about S3 event notifications. What is an event notification? Amazon S3 notification feature enables us to receive notifications when certain events happen in our S3 bucket. This means it provides the ability to trigger notifications when certain events happen, like adding a new object into S3. Here, to enable notifications, we must first add a notification configuration that identifies the events we want Amazon S3 to publish and the destinations where we want Amazon S3 to send the notifications. So let's take a look at how these notifications work. So in this example, we have a user and bucket within S3. Now let's make an operation like put object into bucket. And here what S3 does when we configure S3 to trigger a notification, and that notification can go to three of the AWS services like SNS, Amazon Simple Notification Service. SNS is push notification service where it allows users to push messages to Windows, Google, Apple and certain internet connected smart devices by using an application programming interface or using AWS Management Console. We can also send notification to Simple Queue service. We can call it as SQS. It is a messaging service where it will write messages to message queue. And with the help of SQS, we can send, store and receive messages between software components at any volume without losing messages. And finally, we can send to AWS Lambda. It will allow us to run arbitrary code without provisioning any server. And types of code we can use within Lambda or Python, Node.js, Java and C#. Here are the events that can trigger notification. At first, new object created events. Next, object removal events. This includes deletes of versioned and non-versioned objects. Next, restore object events. And next, RRS object lost events. And what that means is when an object stored in reduced redundancy storage is lost. And finally, replication events. Let's see supported event types for notifications. At first, for object creation, Amazon S3 API support put, post and copy to create an object. We can enable notification when an object is created using a specific API. Then we have object removed. So by using object removed event types, we can enable notification when an object or a batch of objects is removed from a bucket. Then we have object restore. So by using restore object event types, we can receive notifications for initiation and completion when restoring objects from S3 Glacier. Here we have reduced redundancy lost object. We use this event type to request Amazon S3 to send a notification message when Amazon S3 detects that an object of the RRS storage class is lost. And finally, we have replication events that supports failed operation replication, missed operation threshold, and operation not tracked. So in this lecture, we have discussed about event notifications and supported event types. See you in the next lecture. Hello everyone. Welcome to this lab on S3 event notifications. Here we are in S3 console now. And let's navigate to event notification setting under bucket properties tab. Here we have event notifications. Let's try to enable it and click on create event notification and call it as my lab demo events. And here prefix and suffix are optional, and I am going to select this. Sorry, and I am not going to select this. Yes, I want this to apply on all the objects within my bucket. And then coming to event types. So I want the event triggered anytime an object is created. So that is object created by put, post, copy and multi-part upload. And we can also have other events get triggered for object delete events and restore object events also. And then we need to choose a destination. So the destination could be a Lambda function or SNS topic or SQS queue. So for now, we select SQSQ, and here we need to create a new SQSQ. So let's go ahead and create a queue. Click on create queue here, and name it as MyLab SQS notifications. And click on create queue finally. Okay, my queue is created. So now what we do is to set up an access policy. And the access policy I set up will allow my S3 bucket to write to my Amazon SQS queue. So let's edit it. And click on policy generator here. Or else, first let's try to do it in S3 console directly. Okay, let's refresh this page to see SQS queue reflect here. And select MyLab SQS node here and click on Save Changes. Okay, finally it's throwing an error for API response because I am unable to write to my SQS queue. So to fix this, let's change the access policy to allow people to write to my SQS queue. Let's use policy generator here to generate a policy. Select the type of policy as SQSQ policy only and the effect as allow, and principal should be from everywhere. Show it should be as star. And in actions, select send message to SQSQ. And we need to paste a ARN here, and here it will be. And finally create a generate policy. Copy this policy and paste it in access policy here. Finally click on save. Let's try to save this one more time. Okay, it's successful. Now finally let's go and upload an object to see if that triggers an event or not. Now let's go to Amazon SQS queue. Here we can see send and receive messages. Click on this And here under receive messages, we have two messages available, and click on poll messages here, and click on any message here and body of the message also see it. Yes, here we are in the body message now. Here it's showing event as test event from Amazon S3. This is when Amazon S3 was testing connectivity between S3 buckets and SQS queue. And let's check other event. Yes, here it is showing the actual content of the SQS. Now it's showing the actual notification that was sent by Amazon S3 into SQS queue. Like it's showing the source as AWS S3, the region as ES East 1, and the event time that got created by putting their object, and also the principal ID, that means whoever the upload the object, and also the different parameters. So that's the end of this lecture, and see you in the next. Hello everyone, welcome to this lecture. Here we are going to discuss about S3 static website hosting. So let's take a look on what is static website hosting. S3 can be used to host a static website, but static means which contains client-side content such as HTML, CSS, and JavaScript. It can't contain dynamic contents or server-side scripts such as Ruby, Java, PHP, and GSP, etc. Here, to host a static website on Amazon S3, we need to configure S3 bucket for website hosting and then upload our website contents to this bucket. Here, you will need to enable static website hosting option for the S3 bucket so that the static content can be served when accessed over the internet with the endpoint URL. We also configure redirects, web traffic logging, and custom error document with this static website hosting. And static website hosting is extremely low cost because we are storing everything in S3 and we pay for only S3 storage costs for many sites which hold less amount of data, and also we have less pay few dollars each month. Here we no need to worry about automatic scaling or unexpected peaks in demand, which also provides high security. S3 website endpoints. When you configure bucket as a static website, the website is available at the AWS region with specific website endpoint of the bucket. And depending on our region, Amazon S3 website endpoint have two formats. One endpoint is S3 website dash, which contains dash after S3 website name, and other is S3 website dot, which dot after S3 website name. Here I have mentioned one important note, that instead of accessing the website using an Amazon S3 website endpoint, we can use own domain registered with Amazon Route 53 to serve your content. So that's the end of static website lecture, and see you in the next lecture. Hello everyone, welcome to this lab on static website hosting. So in this lab, we are going to set up our bucket as static website. And now let's create a new bucket for this. Click on the bucket. Now go to properties of bucket and scroll it down. Okay, here it is showing static website hosting, that is disabled. Click on edit here and click on enable. So Here we need to provide the index document and error document, but the error document is optional. Give the name for the index document as index.html, and for error document, that is error.html. Click on Save Changes. Now let's upload both files into the bucket, that is index and error documents. Okay, upload both index and error files here. And click on Upload. Okay, files uploaded successfully. And now go to Properties tab and copy the URL. Okay, it's giving 403 forbidden error. Why? Because the bucket is not publicly accessible. So now let's make this bucket as public. Click on Permissions tab here and click on, that is Public Block Access, and do uncheck the Block All Public Access, and finally click on Save Changes here. Now click on Edit Bucket Policy, and now let's create a policy by using the policy generator here. Select the type of policy as S3 bucket policy and effect as allow, and principal should be asterisk. Why? Because we need to allow everything here. And in Actions tab, select the Get Object. And give bucket ARN here by copying it from this. And click on Add Statement. And finally click on Generate Policy here. And paste it here. And finally click on Save Changes. Okay, now bucket is publicly accessible. Now let's see the URL by refreshing it. Okay, the URL is working with the index.html. It is showing hello everyone. So our static website is working perfectly. And that's the end of this lab.